So number 56 reads 2 minus 3x is less than or equal to 5. So first step, we're going to subtract 2 from both sides. We will end up with minus 3x is less than or equal to, 5 minus 2 is 3. Okay? Now, again, we want to end up with x on one side of the equation, and we certainly don't want it to be a negative x. We will divide both sides by negative 3. So here we are, same situation as in number 55. We are dividing by a negative number. That's our cue, that's our sign, that's our rule that says flip the inequality. So we would end up with x is greater than or equal to negative 1. So we went from a less than or equal to a greater than or equal to, simply because we had to divide by a negative number so that we can turn x into x equals or x is greater than or equal to. Okay? So now we have x is greater than or equal to negative 1. We're going to graph it. I always like to start with the graph. It helps me out with some of the other notations I have to do. So I'm going to draw my graph. And a couple of arrows going off into infinity. I'll locate 0. I'll locate negative 1. And I'll see, okay, greater than or equal to. So I know that that will get a bracket because of the equal sign. And greater than, it's going in a positive direction on the number line to infinity. So when I write that as interval notation, I'm going to put a bracket because it does include negative 1. I'm also going to place infinity, and I'm also going to use a parenthesis because the parenthesis and infinity always go together because there is no end to infinity. Hopefully there's no end. You never know. But that's way beyond what we talk about here. And last but not least, we will have the set notation. And we start with our curly brackets, x such that. It's a lot easier to just put that line than having to write out such that each time. X is greater than or equal to minus 1. If you notice, that's the same solution as number 55, just a different formula. Okay? So number 57. You should start to be seeing a lot of repetition here, a lot of consistencies, patterns that'll make these sort of problems actually pretty easy to solve. So when we look at number 7, the situation they give us, 3x minus 7 is greater than 2. Obviously we're going to solve that. We want to get 3x so that it's by itself, pretty standard at this point. Add 7 to both sides. Result is 3x is greater than 9. At this point, we want to divide by 3, so we can just end up with x. Of course, we divide both sides by 3. Now we're dividing by a positive number. The inequality is going to stay the same. It's going to remain greater than. And what we end up with is x is greater than 3. We want to graph x is greater than 3. X is greater than 3. We want to graph that. We'll draw a number line. I'll locate 0. I will locate 3. It is greater than, but it's not equal to. So on 3 on the number line, I'll draw a parenthesis. I'll extend this arrow just a little more so it appears to be infinity. And then I'll draw an arrow there. As I said earlier, some people will just scribble it in like that. In your answer, when your answer's in the back of your book, they just add another arrow. So that's the graph that shows that x is greater than 3. Interval notation. We're going to put a parenthesis. We're going to put the number 3. What that is telling us, that any number greater than number 3, greater than number positive 3, heading off into infinity, could be placed as x, and it would still be a true statement. Parenthesis, because it's not equal to 3, again, to repeat, if it were 3, or x rather, is greater than or equal to 3, then that parenthesis would become a bracket. And again, to repeat, whenever you see infinity, always use a parenthesis. So finally, set notation, our little curly brackets, x such that x is greater than 3, close curly brackets. The reason I like to leave this up here, this helps me write this, and the graph, the line, number line graph helps me write that. Okay, so that's number 57. Not surprisingly, after number 57 is number 58. Okay, I hope that Mr. Irwin is paying attention at this point. I'm sure he is. He always is. How are you, Keith? Number 58 says, "2x." It's always good when I can't read my own writing. 2x plus 5 is greater than 1. Okay? Again, let's evaluate it. Let's see what we need to do. Step 1, I would suggest subtracting 5 from both sides. The result, 2x is greater than minus 4. We don't want 2x, we just want x to equal or be greater than something, in this case to be greater than something. In order to get to that solution, we're going to divide both sides by 2. The result, x is greater than minus 2 or negative 2. Okay? So we need to graph x is greater than minus 2. We draw our number line. Hopefully you can draw a straighter line than I can. Throw a couple arrows in there. Infinity that way, infinity that way. I'll drop a 0 in here to give me a location. I'll locate minus 2, negative 2. I know it's greater than negative 2, but it's not equal to negative 2. So I'm going to have a parenthesis, and because it's greater, I'm going in a positive direction. That's the graph of x is greater than negative 2. We also want the interval notation. I'm going to put a parenthesis, put negative 2 there. This number line, this graph helps me write my interval notation because it is going to be greater than negative 2, but not equal to negative 2. And we are going to put positive infinity there with a parenthesis. So that would be the interval notation. And our set notation, we start with our curly brackets, x such that, just refer back up to your solution, x is greater than negative 2. Close curly brackets. That's number 58. You all have my email address. I have your email address. If at any point you have any questions, email me, refer to the specific problem, and we can discuss it. We can sort of hammer it out. That's number 58. On to number 59. Okay. Number 59, a little different, a little more challenging, a little more fun. 3x minus 1 is greater than or equal to 3 plus x. Let's fix that. 3 plus x. Okay? So I think what I'll do is I'll start by adding 1 to each side. That will give me 3x is greater than or equal to 4 plus x. It's getting me a little closer to where I need to get. I think I want to get this x over to this side. I want to get it away from this side. So I'll subtract x from this side. I'll subtract x from that side. I'll end up with 2x is greater than or equal to 4. We're getting closer. Starting to feel good about this. I'm going to divide both sides by 2. That should be obvious at this point. X is greater than or equal to 2. Okay, so we have x is greater than or equal to 2. We need to do 3 things to it. We need to graph it, we need to provide interval notation, and we need to provide set notation. Okay? So we'll start with the graph. I like starting with a graph. It makes it more visual for me. I can see it on a number line. I'll locate 0. I'll locate 2. Now greater than or equal to 2, I'm going to put a bracket going that way because I know I'm going in a positive direction, greater than. So that would be the graph. That tells me I should be able to read that graph. The bracket will tell me that 2 is part of the solution, could be the solution, and any number greater than 2 through infinity could be replaced, or x could be replaced with that number. Interval notation, okay, we have that bracket because there's an equal to, 2, comma, infinity, parenthesis. That is a way of communicating, saying that any number 2, including 2, and greater than 2, could be used to replace x. It's a different language, it's a way to communicate. And then, of course, last but not least, our set notation, curly bracket, x such that x is greater than or equal to 2, close